Hi guys, hope you're doing well. Hope you enjoyed your day off. This video is going to have 3 parts to it, and each one is going to be for a different day. We're going to really dig deep into linear equations. What we've done so far is graph linear equations by making an input-output table, and then we've identified the slope of linear equations. What we're going to start with today is how do we write our own linear equations when we're given information. And so we're going to kind of walk through the starting point, like how do we get started writing an equation, and then how do we manipulate those equations into different forms. There's going to be 3 different forms to linear equations that we're going to talk about, and then we'll have the basics, which are a horizontal and vertical, and those are going to be special ones you'll have to memorize. So let's flip over here to our .cam so we can take a look at what we've got. We'll make me a little bigger in the corner there. So on the .cam here, you see up at the top, point-slope form. Point-slope form is a particular form of linear equations. And for our purposes, this is going to be the form of the equation that we use to get started writing an equation. So when it says write the equation of the line that passes through the given points, this is going to be how we get started writing an equation. The generic for point-slope form, before anything gets plugged in, is y minus y1 equals m x minus x1. Now, there should be a couple things that you recognize. M is the slope. You might be given the slope, or you might have to find it. Y1 and x1, that's from your ordered pair. So that should look familiar to you from what we did when we had to find the slope. And then this one right here, this y and this x, those are variables that are going to stay in the equation. Those are the variables we would use if we were making a t-chart. So at the very beginning, after we plug in the point and the slope, then we would be able to make our t-chart. All right, I'm going to write this down right underneath it because I want you to notice point and slope. And this is called point-slope form. So you need the point and you need the slope in order to write that equation. We're going to do 4 examples. We're going to use all 4 of those examples to work our way through all of the different forms. Because every homework problem from day 1, you're going to need to use for day 2. And every homework problem from day 2, you're going to need to use for day 3. So you have to do your homework and it has to be correct. So example number 1, and these examples all come from homework, so you'll have some homework problems done. You're simply just going to be given the ordered pairs 0, 0, and 1, 2. In order to write your equation in point-slope, so we can get started, the first thing you have to do is you have to find the slope. This is the most important part because if you don't find the slope accurately, then you're going to have incorrect equations the whole rest of the way. So we're going to start here, and I'm going to set up my boxes to find my slope. And remember, we're going to plug in x1 and y1, x2 and y2. So you got to make sure to label your points correctly. Slope formula is y2 minus y1, x2 minus x1. So this becomes 2 minus 0 and 1 minus 0, which becomes 2 over 1. So the slope is 2. For point-slope form, that is the most difficult part to the process, is finding the slope accurately. Now, I'm going to rewrite point-slope form. And we're simply going to plug in our clues. So let me move this up here. My slope of 2 is going right here because that's m. And then my y1 and x1 are going to come from the points up here. Now, I'm going to write 2 versions of the equation because I could use this as the first point, or I could use this as the first point. So y minus y1 becomes y minus 0 because y1 up here is 0 equals m, and m gets replaced with 2. parentheses x minus 0, because x1 was also 0. Now, for point slope, there are two versions, two options, because I could plug in this point instead. There's nothing that says I have to plug in 0, 0. I could plug in the point 1, 2. Now, as you guys do more and more of these, you'll realize why you might pick one point versus the other. 0, 0 is obviously really nice because we get to plug in zeros. But if I plug in this one here and I use the second point, the y value for the second point makes this y minus 2 equals m, the slope is still 2, and then x minus 1, because that's the x value. For point slope form, for day 1, this is all you will do for each problem. You will find the slope, and then you will plug that slope and the point into the equation, and that's done. That's done for day 1. Now let's do another example. Let's do one with fractions, and we're going to come back to these problems. We'll use these answers at a later time, so we'll come back to these examples. But let's go to example 2 for day 1. And example 2 also comes from homework, and it's 1, 5, and the second ordered pair is 5, 2. So remember, you have to find the slope first. So we're going to go ahead and we're going to set up our slope. And then we're going to plug in. What I'd like you to do right now is just pause this momentarily if you're watching this on your own and find the slope. Now that you found the slope and you're back, let's see how you did, because remember, this is the most important part. In the first box here, it's going to be a 2, because that's y2 minus 5. And on the bottom, it's 5 minus 1. If I labeled my points x1 and y1, x2 and y2, we're going to see those get plugged in here. 2 minus 5 is a negative 3. 5 minus 1 is a 4. So my slope is negative 3/4. This is a fraction. Doesn't make a big difference now, but it'll make a big difference later. We're now simply going to plug into our point slope form. So this becomes y minus 5 equals negative 3/4 x minus 1. I plugged in the 5 for y1 and the 1 for x1 right here into the equation. And then I put the negative 3/4 in for the slope. There's a second equation I could have because I could have plugged in the second point. If I plug in the second point, it becomes y minus 2 because I plugged the 2 in, equals negative 3/4 x minus 5. And again, those are your answers in point slope form. You now got started creating and making your own equation. We're going to go ahead and do examples of your special ones, which are horizontal and vertical lines. These you're going to have to memorize. 2, 4, 4, 4. If I find my slope, this is going to be m equals. On the top, it's going to be 4 and 4, and on the bottom, it's 4 and 2, which equals 0/2. If you recall from earlier in the week, anytime you have the 0 on the top of the fraction, that makes the slope 0. If the slope is 0, that means that this is a horizontal line. And the key now is, how do we know what to write? Well, anytime you have a horizontal or vertical line, you have to look at the ordered pairs. And in the ordered pairs, you should see that there is going to be an x or a y value that matches. Well, in this particular problem, it's the y value that matches. Horizontal and vertical lines will always have that occur, and they play by their own rules. So we're not going to write an equation that looks like these that you see in yellow, because those are normal diagonal lines. Horizontal and vertical lines play by their own rules, and the equation is going to simply be y equals 4. It's not going to have the y minus y1 equals mx minus. Horizontal lines will always be y equals 4. No matter what form of the equation I ask for, horizontal lines will always be y equals. Look at the ordered pair to see what number it is. So let's take example number 4. This is our last one. -6, comma, -1. And -6, comma, 4. We're going to find our slope. And it's going to be 4 minus a -1 and -6 minus a -6. Double negatives become positives. And this is going to give me 5/0. And 5/0 equals undefined. And undefined are always vertical lines. Now, just like your horizontal lines, I want you to look at those ordered pairs right now, and I want you to identify where the number is matching. And yes, the number is matching right here at the -6. That -6 is in the x location, and the equation for a vertical line is always going to be x equals, and in this case, it's x equals -6. All right. Those are your special case scenarios. Now, some of you are going to get really good and really fast at this, and you will identify the numbers at the very beginning. You won't have to wait until you find the slope because you're going to see it in the ordered pairs. Okay, so this is a brief lesson on how to get started writing an equation in point slope form. Find the slope and then plug the slope and one of the ordered pairs into the equation. All right, this is all you're doing for day 1 for each problem. You're going to go ahead and write them in point slope form. And then you're going to go ahead and save all of those, and you're going to use those for day 2. These answers have to be correct. So when you're checking your homework, make sure to correct any mistakes that are in there. That's it for day 1. Day 2 will start here momentarily, and we'll be using these problems to get us through day 2. So let's go ahead and venture into day 2 now. You've hopefully done all of your day 1 homework and corrected it. Day 2 homework is going to take us into probably what is the most important form of a linear equation, and that is referred to as slope-intercept form. Slope-intercept form is going to be helpful for graphing. It's probably the one you have used the most when we did T-charts. It's also the one that's going to have the best and most reliable real-life meaning when we start using this for some projects. So let's bring the dot cam back up here. You've got your slope-intercept form, and your slope-intercept form is going to be y equals mx plus b. All right, that is the generic form of slope-intercept. The key thing to know about slope-intercept is that y is alone. You'll notice we were doing that a lot earlier, which was getting y alone, because that was the easiest way to make our t-chart. M, that letter should look familiar to you. That's the slope. That's always the number that's touching x. So m is the slope. And b is the y-intercept. And a y-intercept is where a line crosses the y-axis. It's where it crosses and intercepts that y-axis. And intercepts are going to have a lot of meaning for us as we move forward. All right, and this, again, this is going to be really helpful for graphing and is going to probably be the form of the equation that you use the most. Well, what we're going to do is we're going to simply start by taking example 1 from earlier in the video. And example 1 was y minus 0 equals 2x minus 0. So this was the equation that we got from example 1 from point slope form. Converting from point slope to slope intercept is really simple. The only times it becomes challenging is if there's a fraction for a slope. I need to start by getting rid of parentheses. So I'm going to distribute the 2. And 2 times x is 2x. 2 times 0 is 0. All right, we'll put it as a minus 0. So we've just got a placeholder. Minus 0 plus 0 doesn't really matter. And then we're going to bring down the equals, and we're going to bring down the y minus 0. And if I wanted to, I could add 0 to both sides, even though it's kind of silly. And when I'm done, y equals 2x. And I'm not even going to put the plus 0. Your y is alone. You are now in slope-intercept form. If I asked you what the m or what the slope was, I'm going to look for the number that's in front of x. Well, the number in front of x is the 2. That's the slope. That's the m. The plus b isn't here, so that means the b would equal 0. So when we're talking about mx plus b, those are the values that we would be looking at. Now, if you recall, when we did point slope form, there were 2 versions to the answer. Once we are working into slope intercept, you're going to realize why you don't have to do this twice. You're just going to pick one of the 2 and convert it to slope intercept. Because for this example, I'll show you what happens with both. The second answer from this example problem was y minus 2 equals 2, parentheses, x minus 1. Well, we're going to do the same thing. We're going to distribute. And it becomes 2x minus 2. Bring down the equals, bring down the y minus 2. I want to get y alone, so I have to get rid of the minus 2 by adding it. And when I add the 2 to the other side, 2's cancel, and I'm left with y equals 2x. And you'll notice I got the exact same answer as I did here. Point slope gets you started, and then converting your point slope into slope intercept, it doesn't matter which one you use because there's only one possible answer for the slope intercept. The point slope had 2 answers because there were 2 points, but for slope intercept, that line has this equation, and that's it. So let's look at example number 2, and we're going to pull the same equation from day 1. So we're going to pull our point slope answer of y minus 5 equals negative 3/4 x minus 1. And I'm only going to do one of them. I'm not going to do both. Sometimes you want to take the first equation. Sometimes you want to take the second because zeros and ones can make life easier. So let's start off here simply by distributing the negative 3/4. So this becomes negative 3/4 x plus 3/4. Bring down the equals. Bring down the y minus 5. I'm going to add 5 to both sides. But I want you to notice very carefully, I'm going to add 5 to this side. But over here on this side, I'm going to add 20/4. All I simply did was take the 5, convert it to a fraction, and get common denominators. You all should have the fraction skills that allows you to know that 5 converts into 20/4. All right, and if you have to work those fraction skills off to the side, that's fine. The 5's cancel, and y equals negative 3/4 x plus 23/4. I want you to have that y-intercept right now as an improper fraction because that's going to be very beneficial to you moving forward. So this was example 1 and example 2, point slope into slope intercept. Now, if you recall, example 3 and example 4 were horizontal and vertical lines. So example 3 was a horizontal line with y equals 4. And if you recall what I said about horizontal lines, if it is y equals 4 in point slope, the slope intercept is also y equals 4. They play by their own rules. All horizontal lines will always be y=. And example 4, if you recall, was a vertical line, and that vertical line was x equals -6, and that's a special one. And vertical lines are always going to be x equals. So this one, even in slope intercept, is x equals -6. There is no change. They are going to be the exact same every single time. So point slope to slope intercept. Your goal is to get y alone. So you are going to get rid of the parentheses and then get y alone. And every time I'm going to be in slope intercept form. If I look at number 2, the m, or the slope, is -3/4. The b, which is the number by its lonesome at the end, is the y-intercept, and that's +23/4. So that briefly sums up taking point slope into slope intercept. You're going to take all of your answers from day 1, and you're going to do this exact same process, and you're going to get y alone. That's your assignment for day 2. Get all of those problems into slope intercept. Day 3 will use all of your answers from day 2, so please make sure to check them and ensure that they are correct so that you can do day 3. You should pause the video now and do day 2, and then bring it back in order to learn how to do day 3. All right, here we go with day 3. Day 3 is going to take all of your slope intercept answers and turn them into standard form. Standard form should look familiar to you because you've seen it at the very beginning of linear equations. There are some rules that I'll show you briefly for standard form. Standard form is the sort of nice and neat and tidy version of a linear equation. It is most commonly used to find x and y intercepts, which we'll do later. And it is used a lot when we do systems of equations. So getting equations into standard form will help with systems, and that's going to be the next major unit to the algebra class. So we're going to start first with the notes for standard form that you should hopefully have in your folder. The notes for standard form, and you're going to see here, standard form of the equation is ax plus by equals c. And this part should look familiar to you. A is a number. It's the coefficient of x. B is a number. It's the coefficient of y. And c is a number. And that's just a constant at the end. There are 4 rules to standard form in order for an equation to be in standard form. The first is no fractions or decimals. So if there are fractions or decimals, you have to get rid of them. So you'll go back to your solving equation skills from earlier in the year and remember how to get rid of fractions or decimals in an equation. The x and the y terms are going to be on the left side of the equals, and the number is going to be on the right side of the equals. The x term is going to be in front. It's going to be first. And we want to make sure that x is positive. So if you need to get these notes, pause and copy them down. If not, you can just get them from your Teams page. All right, so we'll stop sharing that for right now. And then let's bring up the .cam so we can take a look at converting into standard form. So remember, standard form is ax plus by equals c. All right, and there's no fractions or decimals. X and y are on the left, numbers on the right. X is first, and x should be positive. So if I take example 1, and we're going to take example 1 from our slope intercept night, that's night 2, it was simply y equals 2x. Well, if I go through my checklist, there are no fractions or decimals, so that's nice. That works out nicely. X and y are on the left. Well, the y is on the left, but the x is not, so I have to move it. How do I move something to the other side? I'm simply going to subtract the 2x to the other side. So I get -2x plus y equals 0. X and y are now on the left. The plain old number is on the right. X is in front, but it still breaks one rule, which is that x needs to be positive. In order to take a negative x and turn it into a positive, I am going to multiply the entire equation by -1. Now, I only need to do this if I want to change the signs of the equation. So when I distribute a -1, -1 times -2x becomes +2x. So -1 times the y makes this -y, and -1 times 0 is still 0. This equation is now in standard form. You're done. So you have converted that from slope-intercept into standard form. So we didn't have any fractions or decimals. All I had to do was move the x, and then I had to change the sign of the x. So let's look at example number 2. So we're going to take our slope-intercept answer for example 2, which was y equals -3/4 x plus 23/4. So rule number 1, no fractions or decimals. Well, it breaks that rule. So how do we get rid of fractions in an equation? So you need to think back to earlier in the year when we did all of our multi-step equations units. In order to get rid of fractions in an equation, they need to have common denominators. And in this case, they already do. If they didn't have common denominators, you would need to make them common denominators. And now I'm simply going to multiply the entire equation by that denominator. I'm going to distribute, excuse me, moving that around. We're going to distribute 4 times y is 4y. When I distribute here, the 4's cross reduce, and I'm left with -3x. Now when I distribute to the last one, the 4's cross reduce, and I'm left with plus 23. So rule number 1 in standard form is get rid of the fractions or the decimals. Check, I did it. Rule number 2, x and y need to be on the left, number on the right. Well, the x is in the wrong place. I need to move it to the left. So to move it to the other side, I'll do the opposite. So I'm going to add 3x to both sides. And when I do that, I get 3x plus 4y equals, those cancel out, 23. Now, number 2, x and y are on the left, numbers on the right. Check. X is first. Check. X is positive. Check. I don't have to change anything else. This is now in good standard form notation. So I had to get rid of fractions, move the x to the other side, and then I was good to go in standard form. Example number 3. Y equals 4. It's a horizontal line. Remember that horizontal lines all play by different rules. Y equals 4 for standard form is going to still be y equals 4. You should have the exact same answer for this problem for all 3 nights. And then example number 4 was a vertical line. X equals -6. For standard form, it is still going to be x equals -6. You're going to have to memorize horizontal and vertical. So for standard form, you just want to go back and you want to remember your notes. Your notes are going to be the key. No fractions or decimals. X and y are on the left, number is on the right. X term is first, and make sure that x is positive. As long as you do those things, you are in standard form and you will be able to use it for all of the things that we need to use it for at a later time. So this video gets you through point slope form. How do we get started? It gets you through slope intercept form, which is taking from point slope and getting it into y equals mx plus b, which is probably the most useful. And then it gets you into standard form, and standard form is going to be crucial when we get to systems of equations later and for finding x and y intercepts shortly down the road. Hopefully this helped, and this is going to be something you will probably want to refer and look back at repeatedly. Have a wonderful day, guys, and if you've got questions, be sure to bring them up in class.